Good morning, students. In our last class we were discussing mirror formula. So today we are going to derive mirror formula only, right? In our last class we have discussed that the formula which gives us the relation between small f, small u and small v is called the mirror formula, where this small f is the focal length, small u is the distance of distance of object from pole, and small v is the distance of image from the pole. And what is that formula? That formula is 1 by f is equal to 1 by u plus 1 by v. So today we are going to derive this formula, that from where does this formula comes. Okay. Now for this, let us consider a concave mirror where P be the pole, F be the focus and C be the center of curvature. Okay. So let AB be any object placed beyond center of curvature such that a ray will incident parallel to the principal axis, and after reflection it will pass through focus. Now another ray will incident through center of curvature, and after reflection it will follow the same path from where it has entered, and here we will get our image. Our image is denoted by A dash B dash and our object is denoted by AB. Okay. So if I join this line A to P and then A dash to P as well. ठीक है, मैंने क्या किया, इस A को P से ज्वाइन कर दिया और A dash को भी P से ज्वाइन कर दिया. From here we can see that the triangle APB, which triangles I am talking about? The triangle APB. And let APB and triangle A dash P B dash. Okay, I am talking about these two triangles APB and A dash P B dash. I can say that angle ABP is equal to angle A dash B dash P, right? As they both are of 90 degree. Both the triangles are of 90 degree. Similarly, I can say that angle APB is equal to angle A dash P B dash as I is equal to R, right? The angle of incidence is equal to angle of reflection, and this ray AP will be our incident ray and A dash P will be our reflected ray. So by angle axiom we can say that this triangle APB is similar to triangle A dash P B dash, right? This we can say. And we know that one property of similar triangles which states that the ratio of similar sides of two similar triangles is equal. Okay, so we can say that AB upon A dash B dash is equal to PB upon PB dash, right? Give it equation number 1. Okay, now similarly we can say that if I join these two lines such that give it name QM, okay, then similarly in triangles A dash F B dash and triangle QMF, okay, I am talking about these two triangles A dash F B dash and QMF. These two triangles will also be similar to each other. How? As angle A dash B dash F is equal to angle QMF, right? As they both are of 90 degree. Similarly, angle A dash F B dash is equal to angle Q F M, as they both are vertically opposite angles, right? So by angle axiom we can say that triangle A dash F B dash is similar to triangle QMF, and from here we know that the ratio of two corresponding sides of two similar triangles is equal. So we can say that A dash B dash or QM upon A dash B dash is equal to FM upon FB dash. Give it equation number 2. Okay, so this is our equation number 1 and this is our equation number 2. Okay, now I can write this by looking into the diagram. I can say that this QM is equal to AB, right? So can I write AB in place of QM? As we can see that here a rectangle is formed and we know that the opposite sides of rectangle are equal. So I can write AB in place of QM. So what does our equation become? AB upon A dash B dash is equal to FM upon FB dash, right? And on give it equation number 3. On comparing equation 1 with equation 3, what do we get? If this is equal to AB upon A dash B dash and this is also equal to AB upon A dash B dash, so these both must be equal to each other as well, right? So what do we get from here? We will get PB upon PB dash is equal to FM upon FB dash, right? Or if I write it in reciprocal form, then what do I get? I will get PB dash upon PB is equal to FB dash upon FM. Okay, now by looking into the figure, PB dash इसका मतलब पोल से इमेज तक की डिस्टेंस, एंड पोल से इमेज तक की डिस्टेंस को हम लिखते हैं स्मॉल v, राइट? सिमिलरली P से B इसका मतलब पोल से ऑब्जेक्ट तक की डिस्टेंस, एंड पोल से ऑब्जेक्ट तक की डिस्टेंस को हम बोलते हैं स्मॉल u. Similarly FB dash, now can I write this FB dash as PB dash minus PF? I can write this FB dash as PB dash minus PF, okay? Upon में FM, that is F से M. Now if I say that the aperture of the mirror is so small, let the aperture of the mirror is so small such that this M is coinciding with P, so can we write this FM as PF या FP, राइट? अगर मैं ये बोलूं कि जो मिरर है उसका एपर्चर बहुत छोटा होगा, सो इन दैट केस FM is equal to FP. So I am writing it FP in place of FM if the aperture of mirror is so small. Then what can I write in place of PB dash? The distance between pole and image is denoted by small v, minus the distance between pole and focus is called the focal length and it is denoted by small f, divided by f से p तक की डिस्टेंस. इसका मतलब पोल से फोकस तक की डिस्टेंस को हम लिखते हैं स्मॉल f. Now what do we get from here? On cross multiplying these two equations, on cross multiplying these two terms, what you will get? Vf is equal to u into v minus f. From here what do we get? Vf is equal to uv minus uf. Now on dividing this equation by uvf, okay, on dividing the above equation by UVF, what do we get from here? We will get VF upon में UVF is equal to UV upon में UVF minus UF upon में UVF. Okay? V से V cancel, F से F cancel. What do we get? 1 by U is equal to U से U cancel, V से V cancel, 1 by F minus U से U cancel, F से F cancel, 1 by V. Now इस 1 by V को अगर हम इधर भेज दें तो what will it become? वहां पे नेगेटिव है तो LHS में आने के बाद पॉजिटिव हो जाएगा. And from here what do we get? 1 by F is equal to 1 by U plus 1 by V, and this is our mirror formula, right? And hence we can derive our mirror formula with the help of a concave mirror. Okay students, this is the most important topic of this chapter. Okay, so you have to practice it in a very well manner. Now the next topic is linear magnification. You must have noticed that when an object is placed in front of some special kind of mirrors, then a kind of magnification will occur in that in the images formed by that mirrors, right? In case of some mirrors, the image often becomes the bigger than its actual size. Sometimes it becomes lower than its actual size. है ना? That kind of mirrors you might have seen in the zoo also. है ना? So the change in the shape of object in the image while it is placed in front of some kind of special mirrors is called the linear magnification. Okay. Sometimes it becomes bigger than its actual size. Sometimes it becomes smaller than its actual size. So all this happens because of this linear magnification. Okay, so how can we define linear magnification? As it can be defined as the ratio of height of image to the height of object. It can be defined as the height of image to the height of object, and it is denoted by small m, right? So we can say that m is equal to I upon O, where I is the height of image and O is the height of object. Okay, so we can define linear magnification as the ratio of height of image to the height of object is called linear magnification. Similarly, we can also say that the ratio of position of position of image to the position of object is called linear magnification. Or you have to say that the negative ratio of, okay, you have to say that the negative ratio of position of image to the position of object is called linear magnification. M is equal to minus V by U. Okay, so based on what quantity is given to you in the question, you have to solve by using either the height of image and object or the position of image and object from the pole. So I hope the phenomena is clear to all of you. So let us see one simple example of it. Let the height of object is 5 centimeter, and when it is placed in front of any mirror, then its image formed will be of 10 centimeter. Okay, so how can we calculate its magnification? Its magnification will be m is equal to 10 upon 5, that is 2. And one thing you have to keep in mind, that there is not any unit of this linear magnification, since it is the ratio of two similar quantities. Okay. Similarly, you can also say that if the height of object is 10 centimeter and the height of image formed will be 5 centimeter, then the linear magnification will be 5 upon 10, that is 0.5. इसका मतलब क्या हो रहा है? Since the magnification is less than 1, it means that the height of the image form will be less than the height of object. Okay. Similarly, if you know the position of object from pole, let it be 10 centimeter, and the position of image from pole, let it be 5 centimeter, then how can we calculate linear magnification? M is equal to minus 5 by 10 is equal to, acha, here you have to take the distance of image from pole in negative, that is you have to take negative, because by sign convention you know this. And if the mirror given to you is concave mirror, then you have to take V also negative. So what do we get from here? Minus and minus cancel, it will be minus 0.5. So in this way you can find out the linear magnification by just knowing the values of I and O and U and V. Okay. Now the next topic that we are going to study is parallax. Now what do we mean by parallax? Parallax is just a condition that often occurs while we do some experiments related to the optics. Okay. So what do we mean by parallax? When we place two objects at some distance far from each other. Okay. If we keep two pins such that their tips are meeting to each other and they are at some distance from each other. Okay. And if I see it by closing my one eye, and if I move my head, then what will I observe? I will observe that one pin will move like this. Okay. One pin will looks to you stationary, and the another pin will moves like this. This condition is said to be the condition of parallax. Okay. So while doing the experiments, we have to remove this parallax. How can we remove this parallax? To remove this condition of parallax, we have to bring both these objects so close to each other that the relative displacement between them becomes 0, and now when we move our head, both the pins should look moving together. Okay. This case is called the condition of parallax removal. When these objects are when there is a relative displacement between the two pins, then it is called the condition of parallax. When we bring these two pins so close to each other that there is not any relative displacement between the two pins, then that condition is said to be the condition of removal of parallax. Okay. The last topic of the reflection is detection of mirror. Okay. How we can define how we can detect the mirrors, either by touching them, what we call it a single touch method, or just by looking at the image. Okay. There are two ways by which we can identify the type of mirror, by single touch method or by image formed. So first of all we will discuss the single touch method. In single touch method, if I touch the mirror and its reflecting surface is plane in shape. Okay. अगर मैं मिरर को टच करूं और उसकी जो रिफ्लेक्टिंग सरफेस है वो बिल्कुल प्लेन होगी, तो that mirror is said to be plane mirror. The mirrors that we are having in our homes also, that are the example of plane mirrors, right? Now, if I touch the mirror and its reflecting surface is bulging inside, while the polished surface is bulging outside, then that kind of mirror is called concave mirror. Similarly, if I touch the mirror and its reflecting surface is bulging outside, as you can see, the reflecting surface is outside while the polished surface is bulging slightly inside, then that kind of mirror is said to be convex mirror. Okay, so this is how you can identify the difference between plane mirror, this concave mirror and convex mirror, right? Now, but if I tell you to identify the difference between all these mirrors without touching them, just by looking at the image formed by these mirrors, so how can you identify the difference between these all? If you see the image formed into the mirror, and if the image is of same size, if the image formed is of same size as that of the object, then the mirror will be the plane mirror. If the image formed is small and inverted, if the image formed is smaller and inverted, then the mirror that you are using is concave mirror. And if the image formed is bigger and erect, then the mirror that you are using is convex mirror. Okay, as we have discussed the image formation in case of mirrors, so we have seen that the image formed in case of concave mirror is always smaller and inverted, while the image formed in case of convex mirror is always bigger and erect. So this is how we can detect the difference between the mirrors by single touch method and by the image formed by these mirrors. That's all for today's session, students. The further topic we will discuss in the next lectures. Thank you.